Okay, so we have seen the multiplication of exponential expressions that have like bases. Now we will be looking at multiplying exponential expressions with integer exponents. What do we mean by integer exponent? It simply means with positive and negative values. So we'll be taking different scenarios. Okay, so let's start. Our first example for this one will be that we have um, x to the fifth, and I'm going to use the little dot to represent multiplication times, which means times, and x to the fourth. In such case, we recall that the rule for the multiplying bases with exponents that have like bases, we'll be keeping in mind that we will be using this rule: a base to a power times that same base to a different power. We keep the base and simply add their powers. But at no point we have said that those powers need to be positive or whole number or a fraction. Okay, it can be a mixed number likewise, or a decimal. So we'll be taking different scenarios. So in this case, since both of them have like bases, we'll keep the base, which is x, and we'll say 5 plus 4. Let me see if I could zoom in there a little bit so we can see much better that problem. So put it more to the center. Hence we put now the next step to be x to the 9th power, and that's our solution. So remember, we keep the rule that says a base to a power times that base to a different power. We keep the base and simply add the powers. Okay, so it is good practice for us to keep the rule on the side. Well, in this case, the rule was a to the power times that base to a different power. We keep the base and simply add the powers. So I'm going to be keeping the rule on the side with a different color pen so that you can differentiate it. Now let's go with a different one. Another one will be, and I'm going to make my x like curve that way. So x to the 10th power times x to the negative 6th power. Okay, what does the rule say? Well, the rule says that a base to a power times that same base to the different power. We keep the base and simply add their powers. These are now powers which are integers. Compared to these ones here, they are simply whole numbers. So what we do here is that we do the same process. Since bases are the same, we keep the base and we say 10 plus negative 6. Okay, so remember, we are still doing this rule. So then what do we know? We know from the rule of adding integers that if the bases, that if the values are different, then we'll keep the sign of the largest absolute value, and in this case the largest absolute value is 10. So therefore the sign of the 10 in this case was positive, so we keep it to be positive. We don't have to write the positive sign, it is understood. Then we will subtract the smallest from the largest, which in this case is 6. So subtract 6 from 10, giving us 4, and that's our solution for that one there. So remember, for this one here, bases are the same, we will keep the base, the rule doesn't change, but their powers are positive and negative. So what do? We'll keep the sign of the largest absolute value. And what's the largest absolute value? In this case it's 10. So therefore, what was the sign of that 10? It was positive. You don't have to write the symbol for positive. Then we will look at the smallest absolute value and subtract that from the largest absolute value, and then we end up with 4. So that's 10 take away 6, which is 4, and that's our solution. Now let's go to our next one. If you notice, at no point we said that the bases need to be just in pairs this way. They can be combined. So if we have x to a negative 5 times x to a negative 4, then what's the solution to that one there? Well, we come here again and we keep the rule. The rule says if the bases are the same, we'll keep the base and simply add their powers. Okay, and so when we are going to add their powers, we notice that it is negative 5 plus negative 4. That means that we are still continuing adding and more negatives on top of a negative, and since both of them are negative, then we'll keep that sign, which is negative, and add simply the two values, which in this case is 5 plus 4, which gives us 9. So the value is x to the negative 9. That's our solution. All right, so the rule has not changed. The rule is still the same rule. We're just keeping the base and adding their powers. Okay, now let's put some fractions as powers. So now we have here where we have 4, we have x to the half power times x to the 1/2 power. Well, what does the rule say? The rule says that if the bases are the same, we will keep the base and simply add their powers. Nothing has changed from there. Alright, so we'll keep this base, which is in this case is x, keep the x, and now we say half plus a half. Now go back and recall on how to add fractions. Well, if we are adding two fractions and the fractions have like denominators, then we will keep that denominator. So therefore, what do you notice is that we will keep the base, which is x, and since the fractions have like denominators, we keep the denominator and add the two numerators. Okay, so we need to recall the rules for adding fractions. This now gives us x to be 2 over 2. How do I get this 2? Well, 1 plus 1 is 2. But that is not finished yet. Our last step will be that any number divided by itself is always equals to 1. So it's x to the first power, or simply x. That is understood. So the solution to this one here, let's go over it again. The bases which we are multiplying are the same, so we keep the base. We will add their powers, which in this case are 2 half powers. So we put half plus half. The rule says that whenever we're adding fractions, we'll keep the fraction. If they have like denominators, we keep that denominator and simply add the two numerator, which we did here, and that's how we get 2 over 2. But remember, we are only adding the powers of these bases. Okay, so now we go down and say 2 divided by 2, which is 1, or simply x. Let's try one where we have fractions that don't have like denominators. So come now to example 5, and we put x to the 1/3 times x to the 2/5. Okay, how do you work that out? Well, the bases are the same, so we'll keep the base and simply add their powers. So let's keep the base and say 1/3 plus 2/5. Okay, so this is 1/3. So we're keeping the base and simply adding their powers. But go back and recall, how do we add fractions that have unlike denominators? For it not to be squinging up all the work on this piece of the paper, what you can do, you can work the powers on the side and say, oh, let me work the powers. I have 1/3 plus 2/5. This is only the powers. So here is the powers, or what you call exponents. We want to work that on the side so that it doesn't jumble up all of the work on this side. So this is okay. So what is the LCM of 3 and 5? Well, the LCM of 3 and 5 is 15, so we put 15 here, and now we say it's 15 divided by 3, which is 5, times 1, which is 5. 15 divided by 5, which is 3, times 2, which is 6, which now gives us 5 plus 6, which is 11 over 15. Therefore, our solution here can be now x 11 over 15. At times you may end up with a whole number, and that is okay. Alright, so notice what we did here. We multiplied by the two bases. How do we multiply them? We keep the base and add their powers. Their powers are two fractions, so we keep that base and simply proceed with the rule of adding two fractions. Okay, and the working of these two fractions, it is acceptable for you to do it on the side, so that you don't have to do everything here and jumble up all of the work. And notice then less steps shown because you can show the working on this side. So my advice, try to do your work on the side, but make sure you put it in alignment with what you are working with. All right, so let's go to the next one. Consider that you have now a base x 2/5 times x to the 1.5. Okay, now how do you work that out? Well, the rule says that if the bases are the same, you will keep the base and simply add their powers. That is what you're doing. So go back and recall again. How do you add a fraction plus a mixed number? Well, you can do the work on the side. So let's do the work on the side. We put 2/5 plus 1.5. You may add the whole number separately and add the two fractions, or you may convert this mixed number to an improper fraction. So let me work the 2 piece here. So this is now 2/5 plus 1 times 2 plus 1 3, which is 3/2. So I have just converted this mixed number to an improper fraction, so I can add two of them together, not separating the whole number. But you could have separated the whole number and work the two fractions separately, okay, whichever way. So what is the LCM of 5 and 2? It is 10. So we put 10 here, and now we say 10 divided by 5, which is 2, times 2, which is 4, plus, bring down that sign. If this was negative, you bring down negative. 5 divided by 2, which is 5, times 3, 15, which is now 19/10. Or, since it is 19/10, you may rewrite that solution to be 1 9/10, okay, or as an improper fraction. So now come back here, and since we did not want to show all this work in jumble up here, we put x equals to 19/10, or x equals 1 9/10. Either way, it is correct, with the exception that if they tell you state your exponent as an improper fraction or as a mixed number, or don't express it as a mixed number, then that means this must be the correct answer, okay, depending what are the rules. All right, so let's go with some other examples. So remember, all of these are still multiplying bases which are alike, but we have exponents. So let's go with one where we have where we have done the unlike denominators. Let's go ones where we have bases mix. Now we have, that was example 6, going to example 7 now. Consider that we have a base a, b, and base a is to the power 2, b is to the power of 3, times a 4, b 6. Okay, how do we work that out? Well, the rule says, and we must always recall this rule if we're multiplying bases. The rule says that if the bases are the same, we'll keep the base and simply add their powers. Okay, that is what we will need to be doing. So keep the bases and simply add their powers. Now, do we have like bases here? Yes, we have this like base and we have this like base. So what you can do, you can move them together, and because it's multiplication, you can simply say a to the second times a to the fourth, and then bring this next one, b to the third times b to the sixth. So we have just like say group them or bring them closer so you can see who will be multiplied with who. And now this rule can be much more easily seen. Now this base is only given as letters. This doesn't mean it has to be the letter A. This can be also B, or it could be a number. So we work this out, and we keep now A. This base are the same. We say 2 plus 4. Then we bring down the B. We say 3 plus 6. Okay. Now we keep the base. We say 2 plus 4, which is 6, and B, which is 9, and that's your solution. So notice, not because we have it this way means that it is something new. We just simply have to like just consider them to be the same bases, all right, which they are, right? So this could be numbers, so this could be letters. It doesn't make any difference. right? So now we're gonna go ones where we have numerical values other than 1 here. So we have now 8 2a to the third times 4a to the fifth. What's the solution to that? Well, okay, let me change this number here 4 to say 7, so that we this will bring us to a new topic. Okay, so this is 2a to the third times 7a to the fifth. Well, the rule says that if the bases are the same, then we will keep the base and simply add their powers. In this case, 2 and 7 are not the same base, they're not the same number. But what you need to do now is just like this previous example, you will group who are alike. In this case, we have 2 and 7, which are two numbers alike. So we can see now, and let me put it in bracket, 2 times 7 close bracket, and put a to the third, and we can put that a bracket again, a to the fifth. We're just multiplying those individually. You could have skipped this step if you want, but I want you to see the steps, so I'm showing you it. Right now, remember, this doesn't mean 2.7, this means times for this purpose. So now we say 2 times 7, which is 14, and the rule says the bases are the same, we'll keep the base and simply add their powers, just showing all of the steps, which now gives us 14a to the 8th. Okay, and that's our solution. So notice here, you could have come from here to here, but this doesn't mean they will always be in twos. They may be 3s or 4 sets. So let's try. 2 times 7 is 14. A to the third times a to the fifth. Well, we keep the base a and we simply say 3 plus 5, which is 8. So you can come from here to here. But if you don't show me these steps and your answer is wrong, you won't get any points. If you show me these steps here and your answer here is wrong, you still get points for these steps. Okay, and this goes even to negative coefficients of these numbers. So let's try a few of them. Remember, we're still multiplying bases. So now we have 9, have 4a to the fifth, b to the third times say a to the fourth, and we leave it as that. Okay, so the rule says that we need to multiply them. So the coefficient of this a is actually 1, so we say 1 times 4, 1 times 4, and we say a to the fifth times a to the fourth, but the b is by itself, there's no b on this side which is visible. Okay, and I'm going to say use the word in any b which is visible, because we can say that there exists a b here, but we can say b to the 0 power, but let's leave that for a later topic. All right, so now we continue and say now 4 times 1, which is 4. The rule says the b's are the same, we keep the base and simply add their powers, bring down the b to the third, we cannot disregard the b, and that gives us now 4a 9b third, and that's our solution. So let's go from here to here now. 4 times 1, 4. A to the fifth times a to the fourth gives us a to the ninth. B to the third is no b to the third here, so that it is b to the third here. You cannot say 0 times b to the third. Alright, so you don't multiply this b to the third with a 0. Okay, now let's put a base which is a little bit more complicated, but it's still the same concept, and this is where we'll close off this topic here. So we have now x plus y to the fifth power times x plus y to the 8th power. How do we multiply that out? Well, it is not complicated. You need to be able to see this problem as if this is saying a base to a power times that base to a different power. We'll keep the base and simply add their powers. we need to be able to do that. Okay, and who replaces the base in this case? Well, x plus y. This is the whole base. This is the whole base. So both of them are like bases. So we can say now x plus y, open close bracket. You cannot disregard the bracket, and find and put 5 plus 8. Right, and the whole process starts over again. X plus y, open close bracket, 5 plus 8 gives us 13, and that's how you work that and that. Oh, so not because you get the bases this way means that you need to expand this out and all sorts of things. Remember, when you're multiplying bases which are alike with their powers, you will keep the base and simply add their powers. Right, and their powers may be in the form of integers, they may be in the form of fractions as mixed numbers, and also as decimals. Right, so decimals, we won't be touching that, but I think we can use the concepts.